If I ask you a question, what is the one biggest problem which is plaguing the software industry, what will be your answer? Well, my answer will be software estimations. In my opinion, this is one of the biggest bottleneck that is plaguing the software industry because we are doing software development, active software development from last approximately 50 plus years and we are still where we were. Estimations are never correct. No, I'm not going to talk about estimations means estimate, not actual delivery date or something like that. All those things everybody knows. I'm going to talk about the biggest problem within estimation. What are the two biggest problem within software estimations? And these two biggest problem within software estimations are first, the inflation of estimation. Second, software estimations drastically reduces the navigation capability of software developers in case of any unforeseen circumstances or situations. Let me talk about inflation of estimation first. But before that, let me ask you a question. If you go ahead and buy a car in the market, the car will price, let's say, X. Now, instead of buying the car, you go ahead and buy all the spare parts of the car. What will be the price of all those spare parts combined if you buy it as a spare parts? Remember, buying a complete car is similar to wholesale buying, and buying all the spare parts, it's very similar to retail buying. Which means when you go ahead and buy the spare parts, it will bare minimum cost you two, three, four times more than the cost of the car. And that is how inflation happens. And that's the same inflation that happens within software development because we want to estimate each and every small things which we are trying to do. We are trying to write one line of code, give an estimation. So just like when you go and buy spare parts in retail, you will have to pay taxes on each and every spare parts. As compared to when you go ahead and buy the car, you have to pay taxes on the complete car. Similar taxes are being applied in terms of uncertainty, in terms of some buffer space, and in terms of testing that functionality separately, delivering that thing separately. A huge tax in terms of inflation of estimate is applied. So if you ask me a complete software when I'll be able to deliver, I can say that within 3 months I'll deliver that software. But if you ask me each and every detail of the software and the way I'll create the detail, I can tell you that that will take more than a year. And that is the inflation of estimate happens. Let me give you one simple example. If you use your Google map and give point A to point B, what you see in your Google map, you see that you will be reaching point B in approximately this much time, right? There will be some time here and there, but in general, unless something drastic happens, you will reach around that time, not exactly, but around that time, right? It doesn't gives you that the next kilometer or next mile you will reach in this much time, right? What if it gives you, the next mile you will reach in this particular time? Let's assume that Google Maps are saying that you will reach next mile in next 1 minute. What if for some weird reason the traffic light becomes red in that 1 mile and the traffic light stays red for 1.5 minute? All your estimate went for toss, right? Now it may or may not impact the overall estimation because you didn't expect a red light in this mile, but it may also happen that you expected a red light in some other mile and you got the green light, right? So things have been balanced out. But what happens in this particular case is that suppose these estimations are for software development, we will do 5 why we couldn't cross that mile before the light turns red. And just look at the amount of time that will be wasted because of that. And within the context of the same example, I can tell you that how it impacts the software developers' ability to, navigate through unforeseen circumstances. Suppose you have to cover this particular mile when the light is green, and for some reason you see that light may be turning red. What you do? You can't avoid that particular timeline, that particular 1 mile timeline, right? Though you will move fast, you will overtake in a dangerous way, and you will try to go beyond the speed limit so that you can cross that light before it turns red. Was that really necessary in the complete scheme of things? Was that really necessary? I don't think so. Around 12, 13 years back, when I used to ride a bike, I saw some people, while going to office, I used to see people who were just trying to, cross one particular signal as if, their Nobel Prize depends on that. But in the overall scheme of things, even if they are faster than me, they are not faster than me beyond 2 to 3 minutes. So 2 to 3 minutes, by risking so many things, reaching office fast 2 to 3 minutes, and maybe because of the elevator, we may end up going in the same elevator. Was that worth it? And that will not happen if we do not consider these small things as, sacrosanct entity in itself. And that is what, in my opinion, is the biggest problem with software estimations. And this is what you shouldn't do. Now, I believe you understood the crux of what I'm trying to say. The more you estimate, the more inflation you create, the more value you reduce. And I'll talk about value in some later videos, but now you will be asking me what to do. Let me tell you. Estimations in the software development organizations should happen backwards, not forwards. I'll do this, then I can do this, then I can do that. Forget about this. Huge backward estimation. This is the time I need to deliver this particular feature product. Okay. Then this is the time I need to deliver these components. Okay. Estimate backwards and don't go to the minutest possible thing. Just stop at the feature and concrete component level things that we need to do this in this possible time. Believe me, our minds, software developers' minds, are amazing enough to come up with a solution for that. Okay, if you ask instead that when you can deliver this component, they will do all the buffering and they will say this, then still they will not be able to do it. That's Moore's law or Parkinson's law. Okay, so estimating in that way creates problem, huge backward estimation, and huge estimations in a bit concrete way. Try it out and see if it makes any difference in the way you are estimating the things. Okay, and don't curse someone just for missing one red light or green light in 1 mile journey. So that's all I had for today. Thank you all. Thanks for watching. We will meet again. Until the next time we meet, good day, goodbye. You take care.